In our intro to Trig, we're going to look at two different ways to describe an angle, both in radians as well as degrees. But first we need to look at some terminology in terms of circles and how angles are measured. So let's give ourselves a circle, and we're going to think about putting this on an XY axis. So this is your x-axis, and this is your y. And all of your angles have an initial side that is the x-axis. So they always go from the center, the origin, and that is one side of the angle. So this is considered your initial side. And positive angles always move in a counterclockwise position. So angles can be positive or negative. And we always think of not being able to have negative measurement, but that's not the case. In the terms of trig, having a negative measurement tells you the direction. So when we have a positive angle, that tells us that we moved in a counterclockwise position to create that angle. And so your angle is going to move upwards this way, and it's going to terminate somewhere. So I'm not really, it doesn't matter if it stops in first, second, third, fourth quadrant. That's not really the point. It's more that the angle opened up this way. All right? And I can call that anything I want, so I'll call it theta. And again, this would be considered then the terminal side of the angle. All right, so each angle has what we consider an initial and a terminal side. Now if I start at this position and I create a negative angle, okay, again, a negative angle just means that I moved in a clockwise position. Right. So again, if I am starting on this spot right here and I start moving down this way, let's say I create an angle, call that beta. All right. This would be considered the terminal side of that particular angle. So again, this would be my terminal side. Okay. But angle theta is a positive angle because it moves in a counterclockwise, and beta would be considered a negative angle. So what we have is we have a way of being able to break down our circles, and so you should all have something that looks like this. All right. And so what we have is we're going to consider putting again our circle on what we call a unit. And so what that means is starting from the center going out, this has the coordinate 1, 0. So all of these coordinates on the axes have these coordinates, say 1, 0. Right. In this case it would be 0, 1. Right. Negative 1, 0, and 0, negative 1. But what we need to think about is right here, because this is the initial side, this would be considered what we call 0 degrees. And as we move, we create a total of 360 degrees. So one circle, one full rotation is 360. Right. Now let's label the quadrants. So this is quadrant 1, all right, quadrant 2. All of our angles terminate in these quadrants. All right, and so we want to be able to label them in terms of quadrants 1, 2, 3, and 4 to know and describe where they terminate. All right. So again, one full rotation would be going all the way around 360 degrees. A half of a rotation would be stopping right here at 180 degrees. Again, I'd be taking 360 and cutting that in half to get 180. Or we could do what we call quarter rotations. So if I take 360 degrees and cut it into fourths, equal fourths, that would be 1/4 of the way would be 90, 2/4, right? Again 3/4, and then 4/4. And so each of these axes have very important degree measurements, and you want to be able to memorize what those are. So you're going to be required to know these measurements and where they are positioned. Now let's start over here. Right. So what we have is when we are looking at changing up. You can see these are all kind of split up into smaller areas, which are going to correspond to different angles over here on our larger circle. If I want to take the circle and I want to cut it up into eighths, so I say I want 1/8 of this full rotation. All right. So 1/8 of 360 degrees is the same thing as 45 degrees. Right? And you can check that on your calculator if you wanted to, just to be sure. But if I take 360 and I want to divide that into 8 equal portions, that would be 45 degrees for each portion. So again, considering this one part right here as being my initial side at 0, moving up this way, this is first mark is 45 degrees. And so what we can do is, because they are equal portions, we can multiply by the number of like kind of pie slices. So this is 1/8, 2/8, okay? And then if we want to consider 3/8, right, 4/8. And so all you're doing is you're just basically multiplying by the multiples. I have one portion of 45, 2, 3, 4. 4 portions of 45. If you're not sure, if I want to go 4 45-degree lengths, right, that's 180. But then if I want to go, say, 5 portions of the 45 degrees, that means that this mark down here is 225 degrees. Again, I already know this one at the bottom is 270. Right? But again, I can take and just keep adding 45-degree sections to figure out where that terminal side is. So these are the terminal sections. If I were to move around the circle, if I want to move 7 of the portions away around in 45-degree increments, I would get to the 315 degrees. And so you can replace these also on this larger circle. So again, if I go all the way up here, this is 45 degrees, 90, 135, 80. You're going to see that I'm labeling the one right in the middle so I can get all the way around to my circle. Right? We can do that for other little segments. So for example, this smaller little segment right here, this is a 30-degree mark. Right? And so to get to the 30-degree mark, what we've done is we've taken this 360 degrees and we've chopped it into 12 equal portions. All right, because you can see I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 equal portions. All right, so again, if I'm starting here, the first little segment I get to is 30 degrees. So you can also think about these as 30 times 1, 30 times 2, times 3, because that's 3 equal portions. So I'm multiplying by the number of equal portions to figure out the terminal side. So 1, 2, 3. If I want to multiply 30 times 4, right? 30 times 5, right? 30 times 6. That means that I'm 6 of the 12 portions around the circle. And you can continue to add 30 degrees, or you can think about multiplying 30 times the portion that you've moved around the circle. Right? And so you're going to notice that, again, we have equal measurements moving around the circle, and you can, again, label your larger circle with those increments. All right? So 60, all right, 120, 150. So I'm going to go through and I'm going to label these increments down here. And you can see now I've actually already completed them all. And the reason for that is because 30, since that's half of 60, I'm going to hit every single one of those tick marks. All right? Now we do need to talk about those ones in the middle, these multiples of 60, because they are also special increments. And what you've really done is you've really taken that 360 degrees and just chopped it up into 6 equal portions to get the 60-degree marks. And that's going to be one of our special measurements, because 30, 60, and 45 are special angles on our triangle. All right, so again, this what we consider going 2/3 of the way through a quadrant is your 60. So 60 times 1, 60 times 2, times 3, times 4, and 60 times 5. All right, and again, then I can get all the way around to 360. So you're going to see that because when I use my 60s, I'm skipping over some of those smaller ones, but when I look in portions of 30, I'm going to have these, all the labels. All right, and so this is going to be important. This is going to help us figure out what quadrants different angles terminate, and then be able to also convert to different radians as well.